All right, this is Isaac Chavez. I'm presenting a project called Real-Time Twitter Word Cloud using Storm and a Twitter feed. So first of all, I'll speak a little bit about the Storm project. Storm project is a project that was developed by Twitter. It's a distributed and fault-tolerant real-time computation engine. And many people compared Storm to Hadoop. The main differences is that Storm is primarily used as a real-time computation, while Hadoop is more geared towards batch processing. Companies and projects using Storm, there's a lot of the bigger companies. We have everything from Twitter to Groupon, Ujala, and many others. The basic architecture of a Storm is it has a lot of parallel when compared to Hadoop. You basically have Nimbus, which is your sort of the master node, and you get Zookeeper, which is an Apache project, and a supervisor in order to control all the nodes that are going to be doing the processing. So let me walk you through my project, which is a Twitter word cloud. So first, let me start with a few definitions. The first definition I want to walk you through is what is called a spout. A spout basically for Storm project means a source of information or source of stream. In this case, I'll be using the Twitter stream as a first spout. Then I got the bolts, and bolts are processing units or processing nodes. As you can see from the code, what I'm defining is this project is going to be using one spout, and each spout or that particular spout is going to be outputting a Twitter stream from the sample Twitter stream feed, and it will produce the first processing bolt would actually, uh, well, I can show you that topology on the next screen. Um, the Twitter sample spout will be a continuous stream of tweets, and then the first four parallel processing bolts or processing nodes will be counting um, the words used on the tweets. And this can be done in parallel, so I actually specified four different bolts for counting. And then those bolts, the output of those bolts will be tuples, and those tuples will contain the word and account. And first I have four different intermediate ranking bolts, which will basically gather all the different word counts into a final total rankings bolt. And the output of this topology, it's a final n count of words with a very specific count. In this slide, I'm showing um, the last bolt, which is the total rankings bolt. And this bolt is writing a file called cloud.json, which is basically going to be consumed by D3 uh, to produce the final tag cloud or word cloud. This is the sample of the project running. Um, you can see all the different words that are coming out of Twitter. And for this particular test or this particular project, I filtered all the words under 3 letters. And normally what you will do is have some sort of a natural language processing engine, but due to time restrictions, I just filtered some of the most common words and work with that. And then the second thing you'll see is the size of the letter of the letter size of the words, it's actually a reflection of the total count. Here's the link to the project. It's found on GitHub. And finally, the instructions to run the project. You can, well, first of all, you're going to need Lane Engine, which is um, sort of the equivalent of Maven for Java. You can download the project from GitHub using a command, for instance, wget. Java should be installed. You should have Java. I usually would recommend the Oracle JDK, and you'll run the following commands, which is the lane deps, which will download all the dependencies, lane compile, which would actually compile the project, and then finally execute document to execute the Twitter workload. Um, Application, you're gonna need to have a Twitter username and a password, since the API has it's not open to the public without authentication. Um, After you're running the project, the project will actually be generating a cloud.json file, and you can download the index.html file that contains the D3 JavaScript in order to generate that core cloud. Should mention some of the credits. Uh, this project was based off the D3 cloud implementation from Jason Davis, which is actually one of the examples on the D3 project, and Nathan Mars, the Storm Starter project, which contains the rankings, intermediate rankings, Java files to generate the final word clouds. And finally, I can show it to you in action on a browser. This is running on an Amazon EC2 instance, and I can show you the JavaScript code, which is basically just executed once, and then every 10 seconds I'm refreshing the project to get the latest cloud uh, from from the Twitter Storm application. Every 10 seconds this will be refreshing, and you can see the different words as they're coming out of that Twitter stream.